Hello! Presenting program of Insertion Sort. Insertion Sort, as the name suggests, has something to do with insert. What is insert? Insert means putting something in. In what? In this case, is the list which is getting prepared. List means the list of numbers. Okay. Now, what is done is, every time from the beginning, the list is tested, seen, and the element to be considered for insert is the next element. The next element means we take one element at a time and put it on its left in the befitting position after finding out where it should be put in. Like for example, here in this case we are choosing the list which is this one. Okay. In this list, the first element itself is obviously there is nothing in its front or on its left. So it is the it is in its appropriate place. But when I look at 25, is 25 present in its appropriate place on its left? The answer is no. That means 25 has to be brought in front. So this is the place where 25 should be. Now, with 25 and 85, what has been done is 85 has been shifted so as to accommodate 25 in its front. The next element to be considered is 10. What is going to happen with 10? With 10, again, we will look into the list from the first. And from the first, when we see that 10 is supposed to be put in this place. So what is done is, 10 is inserted and 85 and 25 are shifted. So in the previous example, I remember the video was on what is right circular shift. Now you see 10 is going out, 85 and 25 are shifting to the right, and then 10 is put in the front. So is it not a right circular shift? Next we look at 15. Look at 15 and see where is supposed to be the place for 15. So we start from the beginning. The first element, it is okay, 15 is larger than this. Then the next element was 25. 25 is not okay because 15 is supposed to be where 25 is. Therefore, what is done is 15 is copied into TMP. So this 15 comes out into TMP. 85 and 25 are shifted to the right. How are they shifted to the right? With the help of the loop that has been shown in the previous video, wherein this 25, 85 and 15 are applied, has been applied with a right circular shift. Then we come to 60. Look at 60. We start checking from the beginning. 10, it is smaller, so 60 is not there, is not supposed to go there. Then 15, 60 is still bigger. Then 25, 60 is still bigger. Then when it comes to the place where 85 is, that means that place is where 60 should have been. So what happens is 60 is put here with 85 being shifted. Then we come to 35. 35 being compared with 10, then 15, then 25. Then when it's get compared with 60, then we stop. 85 and 60 is shifted to the right, and then that means for this amount of numbers, a right circular shift is done. Now you may wonder why we have so many varieties of operations. Why can't we do all the things in the same way? Because there are different cases and different styles of doing it, which is why all these type of varieties are provided. Okay. Now I'll show you the program code also. When you will see the program code, then you will probably understand how the program is applying the theory. Okay. Now I have taken a static allocation of the numbers. Then the work begins from the second position. That means from cell number 1 and goes till the last element, because if you remember, the last element also has to be tested. The first need not be tested, right? And for your benefit, I have also printed the array. The array shown here in each round tells you how the numbers are changing. Okay. So you see, LP stands for the leftmost beginning position to find out how far should I go to know where should the insertion take place. So LP is 0, and the comparison is done with the help of a while loop, because while loop is easy to understand when it is interpreted as long as. So in your logic and understanding, while is good to express as long as. What will happen in this case? As long as the element considered is bigger than the element at the left side, keep on increasing the left side count. You may have to pause this and hear this dialogue once again. That will help you. Okay. So you will find here that P is the position where the current element is, and LP is the element position from the beginning. So in the beginning, LP is 0. So one by one, I go on increasing LP as long as the element I am considering is bigger. The moment I come across an element which is bigger than the element under consideration, I stop there and I do the right circular shift for those elements. The best understanding point here is with 35. When I consider 35, P's value will be, for this case, 5, and LP will begin with 0. With LP as 0, if the element I am looking at and the element in the beginning, look at that, is 35 bigger? Yes, it is. Since it is bigger, LP goes up. LP becomes 1. Is 35 bigger than 25? Yes, it is. So LP goes up. Is 35 bigger than 60? No. Since it is not, so LP stops at 60. And therefore, from this position till the end, there is a right circular shift. Now you have to revise right circular shift. Why is the loop running downwards? That is your task. Find out why the loop is running downwards, and this circular shift will give the effect of bringing 35 in place and shifting these 3 to the right, and finally the answer will show the sorted list at the outside of the loop, final one. Okay.